All right, in today's video reference, we're going to learn a new chapter, solving inequalities using addition and subtraction. So basically, when you're solving an inequality, um, let's go back and just think about that term inequality for a second. It means that instead of having an equal sign, which is an equal equation, you have an inequality sign. So what are your inequality signs? That means two sides that they're not equal to each other. And the symbols we use in math when things are not equal to each other is that maybe something is greater than, less than, greater than or equal to, or less than or equal to. So no longer for this chapter we'll be using much of the equal sign. We're going to be using these symbols for inequalities, which are greater than, less than, greater than or equal to, less than or equal to. So that means when you get your solution at the end, you have to show your solution in a graphical representation. So the graph of an inequality on a number line is a set of points that represent all the solutions of the inequality. So instead of getting an answer like x equals 5, you might have to show that the answer is x is all the numbers less than or equal to 5. So things will look a little different when you get your solution. So when graphing solutions, this is two important things we're going to use throughout this entire unit. If it's less than or greater than, when you graph it on a number line, you always use an open dot. If it's less than or equal to or greater than or equal to, you use a closed dot. And why does that make sense? Because if you had, going back to here, 5 is less than or equal to 5, and you're on the number line, and you're at 5, and you want to do less than or equal to 5, that means that 5 is actually part of your solution, so you close the dot. If I had x is greater than 5, number line 5, sorry, this is just a quick example, then 5 is not greater than 5, so it's not part of the solution, so you open dot it like that. So let's look at some more clear examples here. So here comes the first part. We're going to write an inequality represented by this graph here. So you can see, we'll use x for our variable. The solution's at -2. It's an open dot, and it looks like it's all the numbers that are less than or greater than -2. Looks like it's all the numbers less than. But notice 2 is not part of the solution, so I just wrote, oh my gosh, my bad, sorry, it's been a long day. Sorry, it should be less than -2, like that. So x is less than -2, open dot, so it's not an equal sign underneath. So this one, again, and we're looking at -2 as the solution, but you can see it's a closed dot, so I want to be using one of these symbols. So these are showing me all the numbers that are greater than or equal to -2. So I'm going to go greater than or equal to because of the closed dot. I use the line underneath because -2 is part of the solution, like that. So how do you solve some of these inequalities that have addition or subtraction? Well, the same way you always solved the other ones when they were just normal equations. So if this was, just imagine that inequality is the equal sign. So I'll write it lower here. So we have it like this. If that was just a good old plain equals, you would just do this. You'd minus 19 here, minus 19 here, and you'd be left with -17 is greater than or equal to k. So if you read it the other way, using the little point here, this means that k is less than or equal to -17. A lot of times when we're dealing with inequalities, you want to flip that around, or you can leave it like this, but let's just go, before I flip it, let's just know that when I graph the solution, I'm going to go to -17 on my number line, and because it says k is less than or equal to -17, I'm going to close dot it like that. And so if you flip it around like this, you could rewrite it like this. K is less than or equal to -17. Once you have the variable on the left-hand side, it tells you which way to shade. So it's pointing that way, all the numbers that are less than. So some people like to switch it around. Obviously, I've been doing this for a long time. I'm okay with just having it this way. And I'm like, oh, k is less than or equal to negative 17. I'm going to shade that way. Let's look at the next one, number 2. Negative 13 is greater than negative 5 plus k. One step to solve this one. I'm going to add 5 here, add 5 here. Left with negative 8 is greater than k. Or, in other words, k is less than negative 8. So now I go to graph it. I go to negative 8, not a closed dot, but an open dot. Follow the arrow if it's like the x is greater than, and I shade that way. All right, real world problem, okay? Say you have luggage and you're checking a bag at the airport. The bags can weigh no more than 50 pounds. Your bag weighs 16.8 pounds. Find the possible weight in W pounds that you can add to the bag. So let's think about this. So it can be no more than 50 pounds. So if something can be no more than 50 pounds, you're going to use this symbol because this is the bag you already have, 16.8, plus some amount of pounds cannot be, it's got to be less than or equal to 50. You're not allowed to go over 50 pounds. So this is the inequality you would write. So again, I'll say it one more time. You have this bag with this many pounds, and you're going to add some more pounds, W, but it has to be less than or equal to 50 because it can weigh no more than 50 pounds. So now I'm going to minus 16.8 on both sides. And so my solution would be the pounds W. It's a weird letter to use for pounds. It's 33.2. If I want to graph this solution, I would make some type of number line here, here, somewhere here. There would be 33.2, and I would be a closed dot. And so I could have anything that it was in that direction. So I could have a bag that's 30 pounds, 25 pounds, 0.2 pounds, but as long as it's less than or equal to 33.2 pounds, then I can go with my luggage on that plane. So I'm gonna have you do the guided notes, but I'm gonna make a new video because I'm afraid that this video might not record fully, and I don't want to waste my time on the next part. So stay tuned for the next video.